everyone? So today we're going to be solving the integral of 1 over 1 minus x squared in 3 ways. So let's write that. So what are we going to be doing? We're going to solving the integral of 1 over 1 minus x squared 3 ways. So and I don't mean we're going to do partial fractions 3 different type of ways. Partial fractions will be one of our ways. But I hope to provide you with a way that most of you will not have seen before, or at least may have not come to mind when solving this. So I'm going to show this the first way. So I think most of you would probably be familiar with trig sub and partial fractions, but what happens if you think about it this way? So the first thing I'm going to do is write it this. And a very clever trick comes to mind if you write it like this. Namely, that this could happen. Okay. And simply, if we were to put this, we would simply need to make sure that there's still a 1 there remaining. So we would have to subtract an x, and we'd have to subtract a 1. But an astute observer could notice this. Okay, I'm simply using the linearity of integrals right here. Sorry, let me keep it like this. An astute observer would notice that I'll just put on the side here, x minus 1 versus 1 minus x. You simply factor a negative out. It's simply a negative. So what happens is these two cancel out and just put a negative. So you're going to get plus 1 over 1 minus, these two cancel, right? You're going to get plus 1 over 1 plus x, right? And now you have two very easy integrals. So I'll evaluate them to show that they're all 3 equivalent methods. This, if you do a u substitution, use 1 minus x squared. Hopefully you guys should know this. I'll put it on the side just for my viewers. Use 1 minus x squared. Du over negative 2x is equal to dx. So therefore, you're going to get the integral of, whatever. So you're going to get a negative 1/2, the integral of 1 over u du, which is negative 1/2, the natural log of u, which is 1 minus x squared. Okay, and hopefully this is obvious for all my viewers. You could call this your u, and your du will equal your dx. So you get the integral of 1 over u du, which is natural log of u, which is 1 plus x. So yeah, that's this integral. It's the natural log of 1 plus x. And I'm simply going to use some log properties, so I'll put this on the side here. A natural log of b is the natural log of b raised to the a. So simply this could be written as the natural log of 1 minus x squared raised to negative 1/2. And anything that a raised to the negative b is 1 over a to the b. I'll write that here. And a to the negative b. I want to, you could just think about it like this, right? This is 1, right? A to the b over a to b. And a to the x times a to the y is a to the x plus y. So you're going to get a to the negative b plus b all over a to the b. So this is a to the 0, which is 1 over a to the b. So that's a proof that I'm going to use here, but hopefully you guys should be getting mad at me for doing this. You know what? Why not? You're going to get this. You could simply write it as the square root by definition, or you could leave it like this. And the natural log of a plus the natural log of b is the natural log of ab. That's another thing here, so I'm going to utilize. So I get these things multiplied. So the natural log of a plus natural log of b, you're going to get the natural log of 1 plus x here. So this is our first answer. Boom. Hopefully you guys saw it. I basically utilized the fact that 1 minus x squared could be nicely rewritten as a difference of squares. next method of integrating this. And if you guys have any other neat methods, reminder, I'm in calculus too, so don't put any crazy things out here. Is I'm gonna do trig sub. I first want to provide some motivation though. So hopefully you guys are familiar with this. One of the most important theorems. Not even theorems, it's just important. And what you should notice that sine squared, for example, could be written like this. And you'll notice that in this form, this 1 minus x squared, there's no apparent way to integrate this. It's not like 1 plus x squared where it's just simply arctan, which again is utilized through, you could prove through substitution, right? 1 plus through x equals tan theta, etc. But what's really nice about this is if you play along and say this is x, things cancel out trigonometrically, okay? So if you see from this, to fit this form, I'm going to say simply x is cosine theta. And because we're going into the theta world, right, theta is now our independent variable. Before, x was our independent variable, right? So obviously we would be integrating with respect to x. But because now we're introducing almost like we're introducing a third variable, we need to integrate with respect to this variable. So we're going to take the differential both sides. Now, hopefully you guys know that the derivative of cosine theta is negative sine theta and times its differential theta. So if I rewrite this, I said x was cosine squared, or cosine, and it's x squared, so you would get this, right? And then dx is negative sine theta. I'm going to bring this out here. Boom. And as you see from up here, 1 minus cosine squared is equal to sine squared. So these cancel out very nicely. So you're going to get sine theta all over sine squared theta, d theta. Now, I'm going to bring it to the denominator because I do not know the integral of sine theta to -1. Sorry, I'm just going to write it like this. And hopefully this isn't a pleasant integral, but if you know your tables, which I was lucky enough to just memorize my trig derivatives, you should know that the derivative, I'll prove it up here really, the derivative of cosecant theta is equal to negative cosecant, or you can't even do it that way, sorry. It's just you have to know it's the integral of, this is not negative natural log of cosecant theta plus cotan theta. Okay, and we're obviously having our arbitrary constant, so this is going to turn into this, cosecant theta plus cotan, and then this is plus c. Okay? You could, and just for my viewers, if you want to have fun, I'll just show you how I did it. Is you can multiply by sine theta, you get sine theta all over sine squared, which is 1 minus cosine squared. You could do a u sub here, so you're going to get negative 1 over 1 minus u squared, and then you get back here. But anyhow, that's if you want to do that yourself. So anyhow, we need to now work back to get within our x world. So x we said was cosine theta, and we are interested in the cosecant of theta and the cotangent of theta. So I'm going to utilize a right triangle to help me here. This is standard method. The cosine, by definition, is your adjacent over your hypotenuse side. So you could write it like this. And so, this is side A, so a squared plus x squared is 1. So if you want to solve for a squared is 1 minus x squared. So a is the plus or minus the square root of 1 minus x squared. Because we're dealing with length, it therefore must be positive. So it's the square root of 1 minus x squared. The cosecant of theta, well, the sine of theta is 1 over, the cosecant of theta is, or the sine of theta is the square root of 1 minus x squared over 1. So by definition, because they're reciprocals, it will be 1 over the square root of 1 minus x squared. And then cotangent of theta, well, what's the tangent of theta? The tangent of theta is the opposite side over your adjacent side. So it's going to be 1 over that. So it's going to be this. Plus c. I'm simply going to make a common denominator. And this is our answer. Now let's compare these two from up here. Bring this down. And I want to make this very simple for my viewers to understand that these two are equivalent, which may not appear so at first. But we all know that these two are equivalent because this is the same as the natural log of 1 plus x all over. The 1/2 is the square root. So they're indeed the same. And for my final method, I will perform partial fractions, which for most of my viewers, hopefully you guys would not have to watch, but just for thoroughness, we are going to utilize the standard method where you break it into some arbitrary constants. Okay? Because they're both within an integral, therefore you could drop the integral sign. And I'm going to just multiply both sides by 1 minus x and 1 plus x. So you're going to get this. And again, I'm always a bit perplexed and still how my classmates use this weird method of plugging in instead of doing a more thorough method of simply equating coefficients, which is much more logical. Okay, so I'm going to group my x's together. A minus b, and this is b plus a. Okay, and this is, you could write it 0x. So a minus b, right, is 0. And b plus a is 1. So a is therefore b. So if you substitute it in, you're going to get 2b is 1. So b is equal to 1/2, which is equal to a. Right? So we're going to get the integral of 1/2 over 1 minus x plus 1/2 the integral of 1 plus x. I'm simply going to factor 1/2 out. Right? These are all multiplied. This is like our function times the x. So this is a substitution. But so we're going to get a negative natural log of 1 minus x. So this should be a natural log. And this should be plus. And hopefully this should be apparent. If you do a substitution where this is your u, your du is negative dx. So yeah. Let's just distribute this. I think it's always a bit intimidating. Sorry, we have our arbitrary constant here. Is whenever like you solve an integral different ways and you get weird responses because like they have to be the same, but you just need to simplify it. So again, natural log a times natural log b, they multiply. Okay. What I'm going to do now is carry this downstairs. I'm going to just rewrite its square root. Ooh. So this one gives it a little weird, but what I'm going to do is simply multiply both things by the square root of 1 minus x. Right? Clearly valid because this is just 1. So this is the square root of 1 minus x squared, and this is just 1 minus x plus c. Let's just compare. Perhaps I copied this. Yeah, so let me see how this could be simplified. Let's see. Okay, maybe it would be best to instead multiply by the square root of 1 plus x. I think we'll simply do it, sorry, I should have probably brought it down first to show how the equivalent. So this would be 1 plus x and the square root of minus x squared. Yep, so as you see, same answer. So hopefully you guys enjoyed the video. That was 3 ways to solve the integral. And I think why I wanted to make this primarily was because of this method. It was a very interesting method because, for example, a common integral is this. You get x squared over x squared plus 1 dx, and what you do is you add 1 minus 1 over x squared plus 1. So you're going to get the integral of 1 over x squared plus 1, or, sorry, you're going to get simply the integral of 1 minus the integral of 1 over 1 plus x squared, which makes it much, much easier. So I wanted to sort of try to utilize this simpler way, but it's not really, the standard is the 1, but you could also subtract it in various forms. So hopefully you guys liked it. Yeah.